Okay, this is Algebra 1, Lesson 5.1. We're going to look at identifying linear functions. So how to tell if when I have an equation, if it's a linear function. So our warm-up first involves solving these equations for y. So if you notice, we've got an x and a y. So when we solve for y, we want the final answer to be a y equals equation. So first, I'm going to move this 2x to the other side. So that gives me negative 3y equals negative 2x plus 12, because I can't combine these, so I just write them next to each other. Then to get rid of this negative 3 in front of the y, because it's multiplied, I do the opposite, so I divide. Now if I divide one part of an equation, I divide all parts, and normally we just divide the whole side, but I want to write it out like this. Here's why. I have just my y left. And then these negatives cancel, so I'm just left with 2/3 with an x next to it, plus, or not plus, 12 divided by negative 3 gives me negative 4. So that way I have a whole number over here. And there's a reason for that. As we get later in this chapter, I want it to look like this. Okay? For part 2, they want us to graph this equation, y equals 1/5 x plus 1, for the domain of negative 10, negative 5, 0, 5, and 10. Now the domain are just the x values. So I'm going to make a little chart here. I'm going to make a chart with all my x values. So my x values are negative 10, negative 5, 0, 5, and 10. And then I'm going to use this little part to plug in to the equation part. So times x plus 1. So over here, I'm going to get 1/5 times negative 10 plus 1. Over here, I'm going to get 1/5 times negative 5 plus 1. 1/5 times 0 plus 1. 1/5 times 5 plus 1. And 1/5 times 10 plus 1. Now I need to solve those. So 1/5 times negative 10 gives me negative 2 plus the 1. Plus the 1. So that's negative 2 plus 1 will give me negative 1. Then 1/5 times negative 5 gives me negative 1 plus 1, so that gives me 0. 1/5 times 0 is 0 plus 1 gives me 1. 1/5 times 5 gives me 1 plus 1 is 2. 1/5 times 10 is, that will give me 2 plus 1 is 3. So my points are negative 10, negative 1, negative 5, 0, 0, 1, 5, 2, and 10, 3. Okay? So now I'm going to draw a little graph here. I know that I'm going to need more y values or more x values because they go from negative 10 to 5. So here I need 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. Sorry about that. 5. Oh, hold on. Excuse me. So let me finish. 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my first point is over negative 10, down negative 1. My next point is over negative 5 and up 0, so just on the 0. Then over 0, up 1. Over 5, 1, 2, 3, 4, 5, and up 2. And then over 10 and up 3. So my line's going to look like that. It should be a straight line, which looks nice almost. Maybe use a ruler if that helps you. Okay, so today we're going to look at identifying linear functions and linear equations, how to graph them, and giving their domain and range. So vocab, linear function, linear equation. So let's look at this first graph here. The graph represents a function because each domain, where the domain, remember, is your x value, is paired with exactly one range, which your range are your y values. Okay, so let me word this a little better. As long as you only have one x value for every y value, then it's a function. And I think that might make more sense. So if you look, we have 1, 2, 3, and 4 as our x values, and none of them repeat. You could have a repeating y, in this case you don't either, but the main thing for it to be a function is you have to have only one x value. You can't have repeating x values, okay? Now, if you notice, the graph is a straight line, and a straight line is called a linear function. So first of all, the question is it a function? And the second question is it a linear function? So is it a straight line? So let me show you. So on this first one, we're asking ourselves, does each x value pair with only one y value? Well, if we notice, we've got x, 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 they're all different x's. So yes, it is a function. Now, is it a linear function? Does it make a line? Yes, so it's both. Okay. There's another test I like to use instead of checking if each one has its own x value. There's something called the vertical line test, which means if you draw a vertical line through the graph at any point you draw it, it should only hit one x value. So like if I move across, it should only hit one x value. So maybe if I draw a little line here with a different color to show you. So for example, on this next one, if I draw a line through any part, if you notice, it's only hitting one point on the graph at all those parts. So that means, yes, it is a function. Now, the second question, is it a linear function? Does it form a line? No, but it is a function. All right. Next one, if I draw a straight line, a vertical line through this graph, well, look what happens. Right when I get over it, it overlaps it at a bunch of x values. There's all these x values that it's hitting at one point. So this is not a function. And is it a linear function? Well, if it's not a function, it can't be a linear function. It does form a line, yes, but it's not a linear function. So that's important to note. Yes, it makes a line, but because it's not a function, it's not a linear function. Okay, let's try this next one. So if I draw lines through it, does it hit the graph at more than one x value? Well, if you look, it's hitting it at 2 points there, 2 points there, 2 points there. So no, this is not a function, and no, it does not make a line. So let's look here. You can also identify a linear function by looking at a table of the ordered pairs, meaning points on the graph. So a linear function has a constant change in x and a constant change in y. So what you would do is you would list your ordered pairs. So you'd list your x value and your y value. And if you notice, every x value is unique. So there's not a repeating x value. That, first of all, tells you it's just a function. Now we're going to look, if I go from -2 to -1, that's a change in +1. I'm jumping 1. From -1 to 0, I'm plussing 1 again. From 0 to 1, I'm adding 1. And from 1 to 2, I'm adding 1. So all of my x changes are the same. That's the first part. Now we have to check if the y parts change the same. So from 7 to 4, we subtract 3. If I go from 4 to 1, I subtract 3. If I go from 1 to -2, I subtract 3. And -2 to -5, I subtract 3. So those are all the same too. And because of that, yes, this is a linear function. So as long as both the x and the y changes, that's what we're looking at, guys, the change from each x value to the next, and the change from each y value to the next. So let's try this one. So this one, if we look, our x changes are the same. However, our y changes are not the same. So what does that mean? Well, that means it's not a linear function, but is it a regular function? Well, let's look. I have a -2, a -1, 0, 1, and 2. Do any of those repeat? No. So it is, yes, a function, but not a linear function. And here's, if I were to graph it, I'll show you. So 1, 2, 3, 4, 5, 6, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Those should be equidistant apart. That wasn't a very good job on my part. They should all be the same. 1, 2, 3, 4, 5. I'll do one more. Okay, so if I go -2 up 6, -2 up 6, -1 up 3, 0 or 0 up 2. Sorry, I should go up there. Ignore this one. Over 1 up 3, and over 2 up 6, I get like one of those curved little VUs things. So it is a function because it passes that vertical line test I was talking about, meaning only one x values at every point, but it's not a linear function, okay? So let's try this. Let's see if we can figure this out. So they give us a set of ordered pairs. Let's fill them in. So this is our x, and this is our y. X, y, x. Remember, we always list ordered pairs as x comma y. 16 and then 9. So let's check. First of all, is it a function? From 0, so like I said, from 0 to 4, that is adding 4. From 4 to 8, that's adding 4. If I go from 8 to 12, that's adding 4. And if I go from 12 to 16, that's adding 4. So all our x changes are the same. That's step 1. Step 2 to check if it's a linear function is to check the y's. So from -3 to 0, that means I had to add 3. To go from 0 to 3, I had to add 3. To go from 3 to 6, I had to add 3. And to go from 6 to 9, I had to add 3. So those are the same. So yes, it's a function. And yes, it's a linear function. So remember, if the x values, they have to be unique. That's step 1. And then all of these have to be the same. Let's try another one. So I'm going to fill in my ordered pairs. Okay, so step 1, are all of these different? Are all the x values different? Yes, they are. So that means it's a function. But we have to check if it's a linear function. When I go from -4 to -2, I'm adding 2. When I go from -2 to 0, I'm adding 2. From 0 to 2, I'm adding 2. And from 2 to 4, I'm adding 2. So this is the same. Let's check our y's. From 13 to 1, I had to subtract 12. From 1 to -3, I had to subtract 4. From -3 to 1, I had to add 4. And from 1 to 13, I had to add 12. So are these the same? No. So, goodness gracious, sorry guys. I don't know why that keeps happening. So they do not satisfy a linear function, but yes, it is a function. So yes, it's a function, but not a linear function. Okay. Okay, another way to tell if something is a function is to see if you can get it into a linear equation and get it into standard form. So standard form is when I get all my x's and y's on one side and set it equal to my constant c. A and b have to be real numbers. They cannot be 0. So for example, if I go back to my warm-up, that first one, 2x minus 3y equals 12, this would be like your a term, the -3 would be your b, and the 12 would be your c. So that is a function because it was written in standard form. So let's see if we can do that. So also you have to notice that the linear equation, in order for it to be considered standard form, the x and the y both have to have exponents of 1, meaning I can't have any exponents on them. The x and the y cannot be multiplied together. So if you notice, those are multiplied together. So that's why these are not linear. And also the x and the y cannot be in a denominator. So those are not linear functions. These are all linear. So take a look at those examples if you have questions on what's linear. And then just a reminder, for any 2 points, there's exactly one line that contains them. So if we want to graph something, they're just telling you you need 3 points to graph a line, just to make sure that we didn't make a mistake. All right, so we're going to do a little bit of it. We got 2 slides left, so hang with me. So we're going to first and foremost see if we can put this in standard form. So our x is already on one side, so we're going to move our 2y to the other side. So that means we have x minus 2y equals 4. So is this in standard form? Is our x and y, they're not multiplied together. They both have an exponent of 1. We have a 1 as our a value, a negative 2 as our b value, and a 4 as our c value. So yes, we know that this is linear, okay? But let's check still by plotting some points. So they already have chosen values for us, and this time they chose y values to plot or to plug in, which is fine. You just have to make sure that they get plugged in to the y, not the x. So this is a little different, but it's the same concept. So we're going to plug in 0 into y and add 4. We're going to plug negative 1 into y and subtract, or negative 1 and add 4. And we're going to plug negative 2 and add 4, because that's what the equation looks like. So that becomes 0 plus 4 is 4. Negative 2 plus 4 becomes 2. And this is negative 4 plus 4 is 0. So these are our x terms, you guys. These are our y terms. So I should list those first, the 4, and then the 0, the 2, then the negative 1, the 0, then the negative 2. Now if I go to graph these, I need to make my little dashes. And you really need to make sure you make your graphs neat when you're graphing. So I suggest getting some graph paper if you don't for all these next few sections of homework. So my first point is over 4, up 0. 1, 2, 3, 4, up 0. So right on the line. Then over 2, down negative 1. So over 1, over 2, down negative 1. Then over 0 and down negative 2. Now, like I said, if you don't draw your little dashes equidistant apart, this won't end up looking like a straight line. So yes, this is a function, and yes, it is linear because it makes a line. Okay, these last two, we need to tell whether it is a linear function, okay? So first of all, can we put it in standard form? Well, if you look, the x and the y are multiplied together, and that one was one of our rules that can't be. So no, this is not a linear function because the x and y are multiplied together. Next one, can we get this in standard form? Well, I could move this 2 to the x power over, but if you notice, x is in the exponent, and that's not allowed either. So no, this is not a linear function. So the x is in the exponent. So just a reminder, for linear functions whose graphs are not horizontal, the domain and ranges are all real numbers. So that's just saying, like, if you have a linear function, the values can go on forever. So if I were to draw this line, the reason I draw arrows is because the x, it can keep going if I had a big enough graph, okay? So we'll go over this some more on your homework, and that is all.